My name is Ramon. Two colleagues, we're doing the masters together, the MSc Computer Science. Currently investigating on the topic network observability. So my name is Ramon, Jan, and Sascha. So basically, this semester, Severin, he introduced us to the GNP stack. It's you, John, right? Nice. So that was our base, right? And he was like, okay, it would be cool to actually extend that stack with some open source initiative, leading to a more complete network observability stack based on that one. So with this talk, actually, we show you basically a tech stack which should be pluggable in future and give us a more complete view on our networks in future. So, but actually, we do not want to actually reinvent the wheel, right? So we want to use existing implementations of collecting softwares, of open source projects, and just do some minor adjustments where actually needed to get most out of current work and to contribute to existing projects. We'll talk about, for example, IPFix NetFlow collectors, open source ones we slightly modified to fit into our purpose. And actually, I also wanted to ask you about adoptions, or who of you is using these different network telemetry services already. So, for example, IPFix NetFlow collection, is that something you're using out there for your networks? So maybe raise your hands. Nice, cool. GNP, not GNP, GNMI, gRPC Network Management Interface. Yes, for sure. You have to, right? Obviously, obviously, right? So that win, yeah. And the third one we implemented is BMP, BGP Monitoring Protocol. Also in use. Nice, nice, great stuff. So basically, we want to build something useful for all of us without reinventing the wheel. So to get a really, finally, hopefully, a very nice solution out of it. And Jan will now introduce you to the GNP stack, which is basically John's work so far.
Yeah, well, we cited John there. He mentions that SNMP has been around for a very long time, and streaming telemetry also has been around for a very long time now, but not that many people use it. I've seen quite a few that are in here. But we thought, well, it's a cool project that he started. As Ramon already mentioned, we love open source, and we want to contribute to this project and extend it and help the industry get better access to streaming and telemetry, easier access, make it easier for basically anyone to get access to streaming telemetry. If you wanted to look at the repository, we'll find it on this link. I really love your username. It's awesome. We haven't yet contributed what we did to that repository, but we might, or we hope to. That's the architecture that we have in mind, because at the beginning, what John started, we had GNMI as an ingestion that also outputs data to Prometheus. And right at the end, as a visualization layer, you have Grafana. And we got the task from Severin to extend it with more protocols, with IPFix and NetFlow and BMP, also IPFix NetFlow and BMP. So that's why we have an ingestion layer with multiple different protocols that you can also adapt with even more if you want to. If you want to have syslog or something else, you could do that and pipe it in the end to Loki or something else and visualize it also in the same pane of glass, in the same Grafana instance. So you can have multiple different protocols talking to you and visualize it in one view that makes sense to you. Yeah, so now I'm giving over to Sascha for the BMP.
All right, here we go. Quick show of hands, who has heard of BMP before? Okay, that's very good. Some are informed, some are not. For those who are not, that's this slide right here. So we have BGP, and we have BMP, the BGP monitoring protocol. It's been standardized in an RFC, as most things are. It's quite young in the network space. It's 2016, so that's young in that space. Just yeah. It works by forwarding your BGP session state to a collector. Uses BGP under the hood itself, and does that in the same way that BGP works usually. You have an advertisement if something becomes available, and you withdraw if something isn't present anymore. I'm going to come back to why that's important in our case as well. What's really cool, it doesn't just like monitor your routes or some normal BGP stuff you would do, but it has hidden superpowers if you combine it with additional protocols. So for example, link state is something really cool. You can have your link state protocols like ISIS underlying, and if they're communicated via BGP, you can monitor them as well. That's a really important point here, right here as well. That's why the asterisk is there. It has to be included in your BGP session or your BGP process. It won't be, yeah, I have like a link state protocol. It won't just be magically forwarded to your BMP collector. Just a quick note down here regarding the AFI, SAFI, or NLRI specification. You have different types of network layer reachability information that you can collect using BMP. Those are some examples. They're just identified by their AFI, SAFI pair. The IANA has standardized those as well. You can look those up for any nice combinations that work. So yeah, you get observability of anything you import via your BGP process, anything your BGP process actually selects, or anything you export somewhere else to another BGP peer of yours. So how does our data flow work? The one I designed. You have your infrastructure, and it talks BMP outwards to your collector. In my case, that is GoBMP. Little plug there, nice project. If you're interested in BMP or open source, BGP monitoring, observability, that's a wonderful project. It's not quite there yet. It doesn't have a release schedule and everything, but it works so far, which is really cool. Then in good old GNP stack fashion, we forward to our messaging layer, to NATs in our case, or given by GNP stack as well. And it's a nice thing right here. We use ClickHouse as a database, but we don't actually need an emitter because ClickHouse connects to NATs directly. It's a wonderful thing if you ever need streaming data directly ingested into a database. You don't need like an emitter again, because it just connects there, which is beautiful. And from there on, we no longer talk JSON. We now go back to SQL, which is also nice if you've ever had some database experience. It's pretty much Postgres syntax with some major additions on there, which really scared me. We're going to talk about that as well. And in the end, you get your nice Grafana dashboards. What else? If you're using visualization solutions, you're probably going to be using Grafana. If not, well, that's on you. Sorry. Yeah, those are project names down there. That's the architecture we've implemented so far. You're going to see a little bit more in the demo later on. Regarding some challenges right here, I talked about that BMP uses the classic BGP. Something is present, something has been withdrawn. Something is present, now it's gone again. And when I first started out with this project, I was like, okay, how do I translate that to state? Because those are events. I don't actually have state. What is actually here right now? I only get events. I was like, yeah, thinking about that and almost staying up nights, you would believe it. Like, yeah, that's going to be a super difficult problem. It turns out, yeah, latest timestamp of your event and what kind of event it was. If it's been an addition, an advertisement, and it's the latest timestamp for that specific resource, it's going to be present. So big facepalm moment for me there. It's actually not very difficult. It's pretty easy to do. Depends on how you implement that. Yeah, a beautiful example that I've already seen somewhere else and copied or stole, if you want to say it like that, was using the RIPE internet, the RIPE information service or the routing information service. That's a live stream of BGP announcements or withdrawals that RIPE publishes. You can translate that to BMP and test your collector or my pipeline in that case. I had some problems with that because it's a lot of data. It's a lot of messages. Over like 10 minutes, I got a few gigabytes of data together because, yeah, it's a lot of new routes being announced. Yeah, you've probably heard of the problem as well. And then you go from, okay, those are events, something being advertised, something being withdrawn. How do you calculate the current state of what is present right now? At which point do you do that? It's probably a data engineering question. I'm not a data engineer. I just work with a database right now. So that's how that is going. So do we evaluate at insertion time, which would mean every time I insert an event, I calculate what the current state is. It probably generates overhead, but it will yield very much a fast query. Or do I do it at query time, which, yeah, you don't have a big load, but you will take some time when querying your state. That's the dilemma I have there. Turns out that faster queries are always preferable, especially if your goal is to visualize something or get something presentable. I'm working on that still. It's not quite finished, but like events are presented properly at the current state. And yeah, last thing is creating a good data model. Again, we're working with databases, so data model is everything. How do you store your stuff? Is it adaptable? Do new fields somehow arise? As it turns out, this nice little field here, omit empty, that's a Go struct for those who've never written Go. It defines what a message looks like in Go BMP. In that case, that's not very important. But this nice little field here, omit empty, says, yeah, it can be present, but it doesn't have to be. So if we look here in our JSON proposed data structure, we exactly get area ID, which is going to be stable in our nice BMP message. Well, that's not going to help me. What do I need to expect on my database side? What do I need to receive? What do I need to store of all of that? Do I need to store everything and just set everything to, okay, it's probably a default value, it's probably null, something like that. It's not optimal. We can store JSON in ClickHouse, but that may have some performance issues in the end. Yeah, those are the challenges I have faced and am currently facing. I've found out that storing JSON actually works very fine as long as you don't query over it, which was pretty clear from the get-go. So yeah, that's my progress regarding BMP on the GMP stack so far. You're going to see more of the actual thing later on in the demo.
Right, then let's talk about IPFix NetFlow. So those of you not familiar with that technology, basically what you want to do is getting out some characteristics of actually traffic patterns going through your network. So not necessarily the state of your network, so how your routers are interconnected, but more about information about actual traffic going through. So basically, I set up the whole thing on my home lab because I was like, okay, with traffic, it's kind of more interesting if you have like real world, like say production traffic. So I got an OpenSense at my house and the home lab running a Kubernetes cluster. More details on that right afterwards. But basically, this OpenSense firewall tracks flows. So if like new traffic is entering, a new connection is made. So a flow basically is a unidirectional stream of data from a sender to a receiver. If you connect to a web server, you get two flows, one like taking or transporting your requests and one transporting the responses then. And like during the lifetime of a flow, the OpenSense firewall actually, or the IPFix exporter, basically counts the number of packets being sent over that flow or number of bytes being transferred, and also stores the metadata, so the 5-tuple identification, so who is the sender, who is the receiver, and so on. And that information is then periodically exported using a specified format defined in RFC 7011 It's the IPFix specification. And basically, the collector, in this case, is GoFlow2. It's an open source project capable of reading those messages, can actually interpret those exports. And how that works basically is that there are like some predefined fields. So for example, source destination IP addresses, packet counts, and so on. That's like by IANA as well. And the message format is also told by the OpenSense firewall to the collector with the transmission of periodic template formats. So as a struct in a programming language, you will know, okay, how does my data look like? And GoFlow2, based on that, can then actually parse those messages, can then, which is very nice, can create a binary formatted message, protobuf format, pass that on the message queue on NUTS, and then on the other side, there is also ClickHouse again, so we have some unified stack there, so we don't need an additional database. We can do it together with BMP, which can then read the protobuf messages, consume that from NUTS, parse it given the protobuf definition, and write it in the tables, which is quite nice. And then we can query it the same way as Sascha explained it with Grafana. It's exactly the same thing, just with some different data and different collector. So we have the ingestion, we have the transport, the emission, and the visualization finally. The architecture in my home lab looks a bit like this. So we got the OpenSense firewall, which exports the IPFix messages, it enters the Talos Kubernetes cluster. We got dedicated namespace here running these components, and to enter the cluster, which is use the gateway API of Kubernetes. Like with this IP address, I can connect to the services inside the MSE EFA, so that's our project, these services, and GoFlow2 basically is then reachable over its UDP port where it can receive the IPFix messages. So the challenges I was facing, basically, it was quite straightforward to implement. Also, when I noticed, well, I can do everything with protobuf, so parsing is going to be very easy, straightforward. ClickHouse can actually get the stuff out of it very easily, but the collection, or like the exporter, behaved a little bit strange on the OpenSense, because basically what it did, or like the kind of limited configuration possibilities, is that it always counts flows twice. So it always counts the ingress flow. So for example, if something's sent into IGC2 and goes out to the internet AX0, I get two flows. With, let's say, if it's IPv6, I have no NUT involved, but still I have like the flow twice. Once is ingress flow on IGC2 and once is egress flow AX0. And then it gets even worse with NUT. we also changed like our 5-tuple value identification of the flow. So we changed source or destination IP addresses on the way through. So it gets even more difficult to figure out which flows belong together. So that's why I decided to actually split it up and say, okay, well, I have the problem with the duplicate flows. Like, let's solve that as one thing, which I actually solved inside GoFlow2 collector. It keeps track of like a configurable amount of time, for example, 1 minute or half a minute, whatever you configure, about which exports were already done. So it will keep track of source, destination IP, source, destination port, protocol, this 5-tuple value, and additionally the address of the exporter. We'll save that as inside a lookup table. And when there is another flow which is going to be exported by the OpenSense, once it's sent out to the internet, I get the same 5-tuple value again, and I'm like, all right, that specific flow I already got. And I'm cleaning up this data structure periodically. Basically, that solves the problem with the duplicate flow count in general, but the NUT stuff doesn't really work yet, because there the 5-tuple value is not equal to these kind of flows, because I mess around with the IP addresses. So basically, there I then decided, okay, well, let's do it the way that I just look at the flows in a different way. So I'd say, okay, I look at transit connections, transit flows, so going in the firewall, going out again, and consider the NUT flows as like terminated flows on the public side of the firewall. Look at that separately to avoid like counting NUT traffic twice in statistics as flow counts and traffic volume and so on. So I only do that for the transit ones. But as I have the external flows tracked, I also see like scans going on the internet and that kind of stuff, or VPN tunnels actually terminating on the OpenSense firewall. So I'll see all that. And yeah, so that's kind of workaround which worked quite well. And also, what was a bit challenging is figuring out the direction of flows so that I see, okay, how much traffic is flowing into my network, which was going outgoing, and so on. And I didn't want to do that in query time, so to always figure out, okay, which source address destination does it belong to my local network, and so on, because that's quite inefficient and puts dependencies on your network prefixes to the visualization platform. But instead, I integrated that in the database schema, that there is like Boolean fields, so it's an inbound, outbound, or transit, or local flow, as I call it there, that you can actually query it very easily without messing around with IP prefixes and so on. But that worked quite good with the ClickHouse so far. And yeah, the Grafana dashboard creation takes forever, but it looks nice now, yeah. All right, so I hand over to Jan for deployment considerations of that stuff.
Yeah, you will see the very nice dashboards that my colleague created in the demo at the end. But what I also want to talk about is how do you deploy all those components. Like you have a BMP collector, you have a IPFix collector, you have GNMI collector and emitter, you have some persistency, some databases, you have a Grafana that you need somewhere, and like all those components, if you're not that familiar with them, can be quite hard to deploy. And yeah, I almost forgot nuts. You have a messaging layer in between, like all those components you need to deploy somehow. And my task was to simplify that. And probably not everybody of you has a Kubernetes cluster lying around somewhere. So the thing that Ramon did might not work for everybody. So what I did, or what I started, it's not finished. Sascha's thing isn't in there yet, but it will be at the end of the year, at the end of that project. Otherwise, I probably won't like get the grades that I want to. So, like the first part is I want to have it easily deployable, just with via Docker Compose up. Have some configuration files that you need to provide for the targets, and that's it. And the second, that I'm a cloud native fan, I'm more home in the cloud native world. I want to also easily deployable on Kubernetes, because also you might want to run it in a bigger environment, you might want to scale stuff, and if you're using Docker, you can, but it might get difficult quite fast. So using Kubernetes, in my opinion, way easier if you want to make it bigger and scale everything. And for that, I started to create a Helm chart. You could deploy it right now. You might not get the fancy dashboards yet, but the components are more or less there. But yeah, you will see in probably around a month or so, we'll try to talk to John. So we might merge it into his repo and make it one. And then you'll be able to like get all the fancy cool stuff that we talk about in hopefully an easy way. Yeah. So now to the most important and coolest part. Let's look at some Grafana dashboards. I'll help you switch.
Hashu?
And you'll probably need that dashboard.
I need it on there as well.
Oh shit. Yeah. Now, how do I do that?
Always. It's always gonna go wrong.
Do you need on both? As always, PowerPoint messes with my screen sharing. Come on. I don't want
You can
network.
just drag it over, otherwise.
Can I drag it over? Is that fine? Come on. So.
Oh yeah, that's good.
Yeah, I'm sorry.
No worries. I have a mouse right here. All right, that's my current BMP dashboard of the topology I'm working with. You can already see some nice graph down here. That's not a plugin. That's the Grafana node graph visualization, which is very handy for visualizing things like networks. Super cool. I would recommend using it. It's quite nice. Quick explainer of the topology. We have some central routers in the middle and two of these head routers right here. Those are the ones actually carrying a BMP session between those. So the one currently exporting to my stack is router 1 right here. And everything else is just magically appearing in there as well, because it has link state. That's the thing I was talking about. You can just map up everything that's underneath in here. In this case, IS, which I'm gonna scroll through a bit if I can. Right, you get this nice node graph, your topology, and see which ones you're connected to. You get as well some prefixes, your nodes, everything from link state. So we have our 7 nodes right here, all the prefixes based on the nodes, all of our links which are there. It's also using SRv6, so some segment routing. I heard people are excited about that. Had to. Those are also shown. If we start ingesting this ripe internet statistics stream, again, I could probably, where's your mouse? Oh, here it is. Yeah. Oh, that's nice. Yeah.
Live demos.
Yeah, demo gods, as you said. We see some updated views right here, or they should be updating nearly. Yeah, we can get a lot of data by just saying, hey, export everything that is also part of my current router as long as it has a BGP session somewhere, because every underlying protocol, like internal gateway, every underlying link state protocol is going to be mapped upwards. Those were the ls nodes, ls prefix, ls links you saw there, which is super nice if it would reload, but it won't.
Network error.
Worse. Okay. Yeah. I'm not gonna crash the demo gods anymore. I'm gonna give over to Ramon.
The messed up system. Okay, let's try.
Yeah. Messed up system. Your turn now.
Okay.
Let me help you.
Okay, thank you.
A little bit at least. As my messed up system crashed your demo. Hopefully this one still works. Looks better.
All right. Yeah, as I told you before, that's going to be a tricky one, but okay, we'll manage. So we have, like I split up the whole thing into external flows and transit flows. The external one's just giving me some information about internet statistics. So if I go this one, public links, it's actually quite interesting to see that if I go a bit like 3 hours or so, like the ratio of flow count, I think that's the flow count, right? Yeah, flow count, that I have much more incoming flows than outgoing. Like in an ideal world, this would be like 50-50 probably. So, but there like some indication that incoming flows are getting dropped, for example. And as we see that most likely happens on IPv4, so our scanners out there working hard, right, to figure out some services. IPv6, we have like more or less 50-50. So those gives us some information about the WAN links going on, also about like external IP addresses connecting to our systems and so on. So these, for example, are the DNS servers I'm using, the internet service provider, and then down there, like, so it just helps us a little bit to figure out, see some anomalies. So if one IP address starts doing like huge scans and so on, we can see that appearing down here. And if we are actually interested in the logs, we can go here and also filter around, for example, say we want to filter for SSH destination port something and see what's going on there. What's actually more interesting, those are like the transit ones, because here I only see like external things going on, VPN, statistics, so on, or scanning. But what's really interesting is the transit stuff, because there it a little bit depends on what your needs are. For me, I want to actually see what's going on in the Kubernetes infrastructure, and especially important to me was IPv6 adoption rate. So maybe we're gonna open this one. It's an easy one. So I got a 97% as last 6 hours. Maybe we go a little bit back. So maybe there's some last 7 days, for example. So we have 87% adoption rate on traffic volume, saying, okay, 40 gigabytes of IPv6 traffic in the last 7 days, 5.77 gigabyte of IPv4 traffic. We got 53% only adoption in like flow count, which yeah, maybe like has its reasons of like using some DNS IPv4 DNS servers still on the link, which is IPv4 only, and that's how it evolves over time. Other things being done is like the analysis of like directional ways. So I have like the red one is like inbound flows. That's like the traffic volume. Well, yeah, the volume. So 66% of inbound traffic, 23. I can not even read it, but 20 of local, and yeah, and then see it like anomalies. It's nice to see that over time. To see, oh, here I had a spike. I can go here ahead and like apply a filter, and then down here I have more information on those specific flows and see what's going on, which is quite interesting. And the comparison on flow count is as well here. And the one which goes a bit into more detail is the statistics one. So basically, I added again this chart here to be able to filter again for this specific period of time. And then I see, for example, here is like any direction. So I see inbound, outbound, and local flows. I can say, okay, I want to see only like the local ones in that period, and then I have my local IP addresses here, the top talkers, protocols being used, the peers which transferred most data in that specific amount of time, and here the flow count specific statistics. Both was traffic volume, and here's flow count, and yeah, that just gives some insight into the characteristics of what's going on in my networks, the anomalies. For example, once I figured out that like there were some Brazilians connecting to the systems producing hundreds of thousands of flows, I was like, okay, something's going wrong there. Saw that in the timeline, zoomed in, and was like, oh, okay, that's like 50 different public IPs of the same range doing some nasty stuff. And then I just like blocked them out, and then I had the normal rate again. So it's quite interesting to have an insight into this. Yeah. So
now that we saw the very nice demos, hopefully you found that interesting. And I would like to open it up for like any inputs that you might have, like get maybe a little discussion going. Did we do it something in this sense that might be interesting for you, John?
Right.
It's a very good demonstration of what can be done when you actually move into a proper streaming telemetry stack. And I think one of the, if anyone hasn't read it yet, I mean, first of all, the Git repo, very empty. It's not supposed to be full yet. This is a long-running, slow-burning project that a few of us have kind of got together off the back of the Network Automation Forum, who have kind of decided that SNMP has had its day in the sun. All the love in the world for Tobias Oker, you know, a legend of the Swiss community. However, come on, let's move on. LibreNMS is a wonderful tool, and I'm not saying we need to replace it, but we do need to enable people to access correlation. Mm-hmm. That's the key. So I wouldn't recommend you look at the Git repo because it's a fantastic piece of code. It's coming. It's happening. Right? It's in flux. However, there is a lovely piece of archaeology. It's a little essay that I wrote. It kind of says where we have the problem today. The SNMP is a 1980s technology that has persisted to today, and networking is showing its. I mean, how much grief do you get for SRP6 constant? It's because it's hard for us to move forward as an industry, right? Streaming telemetry is the perfect example of that. How old is the RFC? The reason is that it's hard to pick up. So I want to fix that problem. I want people to be able to get the experience. Get LibreNMS, you download it, put a couple of SNMP strings in, you've got 700 metrics, and it works, and it's fantastic. But you can't really easily correlate a problem here and here. Mm-hmm. It sucks. Grafana can do that for you. Not only do you have these sexy dashboards, you can go and build any query you want, line after line after line, and build that. If this happens, and this happens, and this happens, I've got a problem, I need to page someone, get them out of bed. What I want to do is keep more engineers in bed. That's the aim. That's the goal. That's why everyone, please join the party. When this thing has actually got MVP, which we expect to happen around December, January time, take it, try it, figure out why it works and doesn't in your infrastructures. If you are someone who likes the programming, commit to that. If you're someone who likes building sexy Grafana dashboards, commit to that. Right? If you are someone who can say, I've got this vendor and you don't, let's do that too. Because I think that we have an opportunity here to create something that will give us the Libre NMS for telemetry. And that will then push us into a very interesting era where the service providers have had all the cool toys for freaking ages. I want them too. I don't sell my network. I'm a cost center. So I need to make it free or cheap. That's the aim with the GNP stack. I appreciate the work you guys have put in so far. It looks amazing. I'm very, very excited to see where it goes next. Marco and I have got a lot to chip in as well to bring it up to spec on the basic side of it. But I think this is a real opportunity to turn something around that the industry will actually appreciate.
Yeah, I think it's for us like studying. Like we have free manpower, and if we can contribute to, well, free, it's our time. I mean, but if we can contribute to something that helps the industry, it's always the most interesting from, at least on my side. If I can contribute to something that will help somebody get something easier or have it easier, I love to do that.
It is such an underutilized resource. And I'm in the third company in a row now where I've had to build it from scratch, and I'm sick of doing it. I want it on the internet.
We only can help you. I mean, you, the industry, if you come to us and say what you need, right? Because I kind of struggled the last years because we kind of built stuff nobody's using, right? And now John said, okay, this would be nice, and they built that, and I hope it will be used in the future. So this is also why I search if you need help somewhere. I think we have like pretty solid students can help. They have like the knowledge about Kubernetes, you see it here, and also fancy new topologies and protocols. So you're here, just hit me up. And we can talk about that and hopefully make something work in the future. And this goes to everyone here. So thank you very much.